A cylindrical capacitor. A cylindrical capacitor of length air, total length is air, formed by two coaxial cylinders, this one and this one, of radius A, smallest a, this big is B. Okay. We assume that air is much larger than B. It's very long, okay, so that we can neglect the fringing of the electric field that occurs at the ends of the cylinders. Each plate contains a charge of magnitude Q. Inside is positive Q, outside is negative Q. Okay. This is the field, electric field, from positive to negative, symmetrically, cylindrical symmetry. We want to find the E, okay, at this point, any point, for example, this point. And we make a Gaussian surface, which is a cylinder, okay, cylinder with radius R. And the magnetic flux through this cylinder, we have three parts, okay. This is an E dot dA, whole integration, have three parts. One is E dot dA top, on the top. One E dot dA side, this is a circle, okay, a cylinder, okay. And one is at the bottom, E dot dA. Okay, we know by symmetry reason, the E is always along the radius direction. So on the top, okay, top, dA is towards U. E is perpendicular on this surface, so E dot dA is equal to 0. On the side, dA is towards along the radius. E is along the radius. So E dot dA equal to E dA integration. And by symmetry reason, E is constant. So we take it out of the integration. And integration dA become A. So the side, on the side of the cylinder, the E dot dA integration equal to EA. The same reason at the bottom surface, E perpendicular dA, because dA is, in this case, it put inside, okay, 0. So F for the Gaussian surface is EA. And this A. A is the surface of cylinder. It's 2 pi r circle L. This is the area of the cylinder surface. Now, we use the Gauss law. Epsilon phi equal to Q. Q is the charge here, okay? The charge here, all right? So the phi is E 2 pi L R equal to Q. Then we find the E. E is Q over epsilon 2 pi L L. E is not constant. It's inversely proportional to R. The smaller the R, the larger the E. Okay? Now we can see from the electric line, okay? Inside is more tense, more closer, the larger E. From E, we got a V. We got a E dot dr integration. We check the loops from inside along the radius. So E is not constant, okay? So E, but here, we're choosing this line, E is parallel to dr, right? Yeah, so E dot dr equal to E dr. From positive to negative. And E is, this is E dr. E is this one, put this E inside. And the equation is from R equal to A to B. We put E, okay, Q over epsilon 0 2 pi L dr. So actually the integration is dr over R, okay, from A to B, okay. Then we take the constant out, Q over epsilon 0 2 pi L dr over R integration from A to B. This is log, okay. So finally we got this Q over 2 pi epsilon 0 L log B over A, okay. We have V, okay. We have Q, then we have C. C equal to Q over V, okay. This is Q over V. You have a Q cancel out. move becomes 2 pi epsilon L over log of P over A. See, the C is completely decided on geometry, log of P A L. Nothing to do with V applied to it.